For today's project, we're going to be mechanical engineers, and we're going to build a zipline racer. Our zipline racer will use the concept of conservation of energy to zoom down a zipline across our room. Now that we know what we're building, let's make sure that we have all of our materials ready. Inside of our bag, we should have 4 pipe cleaners, 4 large popsicle sticks, 4 small popsicle sticks, 3 medium binder clips, 2 large rubber bands, 4 large paper clips, 1 regular 2-blade propeller, and outside of your project bag, you should also have a blueprint worksheet as well as 2 pieces of cardstock paper. For testing, you'll also want a fishing line roll, and you will also need a pen or pencil, some tape, and a pair of scissors. Once you have all of your materials ready, we can start building our project. Since this is an engineering design challenge, we need to start by creating our blueprint. Keep in mind that not everyone's design will look the same, but we will be showing you a sample project that your students can use if they're struggling to come up with a design. Now, for the goal of our zipline racer, we're going to have a zipline, and we're going to need it to attach to it. So I'm going to use the paper clips to attach to it. I'm going to build a body on popsicle sticks that will be our actual racer. And then we want to add a propeller somewhere, which will allow us to propel our racer forward. I'm going to put it in the front because to me that makes the most sense as a place to put it. And I'm also going to show how we're going to attach some rubber bands to this propeller, possibly to the back, in order to tighten it up and allow it to propel the zipline racer forward. Now that we're finished with our blueprint, we can start by creating our design. Let's start by adding a propeller to one side of a small popsicle stick. So the propeller should have a little slot in it here that will fit right over the end of a popsicle stick, like so. And make sure that it is attached securely. So I'm going to press it on quite tightly. Now, let's grab another small popsicle stick and tape it to the bottom of your original popsicle stick. I can even overlap them to increase the strength here. And you're going to want to use enough tape to ensure that the popsicle stick is securely attached to your original popsicle stick, since there will be a lot of force applied to them. Then, grab a paper clip, and we're going to bend it slightly so that it looks like a heart. So I'm going to pull out the middle portion and bend it so that it looks like a heart, just like this. And we're going to attach the paper clip to the bottom of the popsicle sticks on the opposite end of the propeller. So here's the propeller, and we're actually going to do this with a binder clip. So I'm going to grab a binder clip, and I'm going to pull it apart like so, and you can pinch these 2 sides to open it. I'm going to take my paper clip, and we're going to want to line it up so that one of the sides of the heart is up against the paper clip, and then we're going to pinch to secure with a binder clip, just like that. All right. Next, we're going to take one of our rubber bands and we're going to thread it through the bottom of the propeller. There's a little hook on the propeller. So we're going to thread it through here, just like so. And then the other side is going to hook into the heart, other side of our heart on our paper clip on this side. Now, in this case, I can see that I've got a lot of tension on this paper clip, and you can see the binder clip was not enough to hold it on. So we can go ahead and secure it some more with some tape. Oops. All right. So I'm going to attach our paper clip, not all the way, but just about here, where it's still a little tight, with some tape. And then re-secure that binder clip to keep it on with some pressure. And if you want your propeller to spin faster, you can even add another rubber band between these 2 points. But you can see now, if I wind up the propeller and then let go, it spins on its own using that rubber band there. All right, so we've now created the propeller mechanism and we can move on to the body of our zipline racer. Now we're going to create a simple square as the body for our zipline racer. Let's start by taping one large popsicle stick perpendicular to the top end of our propeller mechanism. So that will take a large popsicle stick and we'll tape it here facing upwards, like so. Then we'll tape another one after the binder clip on the other side, just like so. Then we're going to want to connect these two at the top to complete this square. We can do this instead of 2 small popsicle sticks with one large one, like so. And there is our square body with the propeller at the bottom and just taped on like so. And now we need to add a way to hook our racer onto the zipline that we're going to create. So grab another large paper clip and you're going to bend it into an S shape. So unlike the heart, we're actually going to keep bending it. So I'm going to grab the middle and I'm going to bend it out like so. And in this case, it kind of bends out, not as an S, but more of like a big C shape, like so. And I just bent the middle out. And you're going to want to hook one end of the paper clip to the top popsicle stick, and then the other side should stick up out of the racer. So securely tape this bottom hook onto the popsicle stick, like this. And if you don't want to use the paper clips here, we could also use our binder clips as hooks to attach to the zip line. And then repeat these steps with another popsicle stick and a paper clip combo. So I'll take one more paper clip, open it up like so, add some tape, and securely attach it. Also mind that the zip line is going to go across this way. So I'm actually going to bend these paper clips so that the hooks are facing forward, meaning that a string could go through the middle instead of them being flat. Finally, we want to make our racer more aerodynamic by covering the empty space inside of our square, which will allow it to move faster and it won't sway as much side to side on the zip line. So what we can do is we can take our cardstock paper and trace the square shape of the body onto the cardstock. So I'm going to trace just the inside very roughly, like so. And then I'm going to cut out a square that is slightly larger than that shape, since this was fit to the inside of our racer. This does not have to be exact at all. And then if you want, you could also encourage your students to decorate the cardstock that they're putting on the outside of their racer to make it look nicer. Now that I have it like this, I'm actually going to just clip it on with the binder clips. So I'll put this one back at the bottom. Oops. I was adding pressure onto this paper clip to make sure it doesn't fall off, so I'll add it back. And I'll add another binder clip at the top that will hold it on. And then flip the legs down. And now we have a body that's making it more aerodynamic. We have our propeller, and we have our paper clips, which are going to hold it on to the zip line. So to test your zipline racer, you're going to want to use the provided fishing wire to make a zipline in the classroom. So you can't really see it on the camera, but there's actually a wire that I'm running my hand along right here. And there are some things to consider when setting up the zipline wire. So the fishing wire is clear and it's very hard to see on certain backgrounds. So it's recommended to not put this in any high traffic area, put it somewhere off to the side, and also maybe put it at waist level instead of where it could get in someone's face. And you also might want to set up multiple zip lines next to each other, going to the same direction, so that students can have their zipline racers next to each other and race to see who's the fastest, or you could just have multiple students testing at once so they don't have to wait. Now to set up the zipline racer, remember you're going to use these paper clips that are on the top to hook onto our zipline, just like so. So you can see it's hanging. And then all you're going to do is tighten up the propeller in order to give it energy to go forward. So if you spin your propeller one direction, it will make a clicking noise and it won't tighten up the rubber band. That means you're going the wrong way. So instead, spin the propeller in the opposite direction. And from my experience, you have to spin it a decent amount. And the more that you spin the propeller and the more energy that is stored in the rubber band, the better your zipline racer will perform. And here, the limits that we get up to is the strength of the rubber band and the strength of the body of the zipline racer that the students built. But once you've got the propeller all tightened up, I will hook my zipline racer back onto my zipline. And then you can have your students line up, count down, and then release both the propeller and the zipline racer at the same time. Just like that. Now that we're done testing, let's talk about how our zipline racer works. Our zipline racer works because we are taking energy and storing it as potential energy inside of the rubber band, and when we release the propeller, this potential energy is released as kinetic energy, which is energy in motion, and potential energy is just stored energy. So as we spin the propeller, we are building up potential energy into the rubber band. And this is also called elastic energy, which is another form of potential energy, which is created when an elastic object, such as a rubber band, wants to return to its original position. So as we spin our propeller, we are creating a force called torque, which tightens and twists on the rubber band, storing this elastic energy. And as we know from the laws of conservation of energy, energy can never be created or destroyed. It can only be transformed. So in this case, when we let go of the propeller, that potential energy, that elastic energy does not go away. It is transformed into kinetic energy as the rubber band tries to return to its original state of not being twisted up. So this energy is released over time, which turns back into torque and spins the propeller. The propeller is angled, which forces air behind the zipline racer, just like an airplane. And this energy propels the zipline racer forward, pushing it down our line. If we had just pushed our zipline racer, it would have been one large boost of energy that would have gone away over time, but the constant release of that potential energy allows the zipline racer to continue gliding down the zipline. So now that you know how your zipline racer works, there are some questions that you can think about with your students, such as what materials would make our zipline racer better? What about our zipline? How could we improve that? Can you make the racer glide faster, and how? And how could we make our zipline racer useful, or what could we use it for in the real world?